Right, I've got a single-phase motor here. We can tell it's a single-phase induction motor by that big lump on the side. That's the capacitor. They use it to make it start. Exactly. And so what we have here, without the capacitor, without that phase shift, we don't really have a true rotating field. We just have an oscillating magnetic field. With the phase shift in there, an additional set of windings, we have an offset stagger that gives the field a definite rotation. That capacitor is engaged or disengaged through a speed switch that's actuated here on the rotor, a little flyweight mechanism. As the weights fling out, they cause that disc to draw in, and that breaks the electrical contact down here and disengages the start winding. There are some single-phase motors that leave that start winding constantly engaged. They're designed a little bit differently here. For higher starting torque, though, what they do is they design a starting winding that draws a lot more current. So it gives a tremendous starting torque, and then when it comes up to speed, it disengages and runs as a single-phase motor. But like any induction motor, we've got the rotor right here. Here's a shorting ring. There's another shorting ring over here. Underneath the iron is actually bars here where the eddy currents will circulate. I'm sorry, go ahead.
I think you can kind of see them.
Yeah, you can kind of see them here. Exactly. You can see the diagonal slots right there. They actually fill in this space here with iron just to make a good magnetic circuit from one stator winding to the other. They could make a rotor purely out of aluminum, but since aluminum is non-magnetic, that would tend to weaken the magnetic field across the stator. So they fill in the gaps with iron to make a good magnetic circuit. But it's really the aluminum that lets the current circulate and does all the work. So there you go. There's a cooling fan right there on the shaft. There's the rotor. We've got a place where it fits into the bearing. And this particular motor being single phase, it's got the starting switch, the starting capacitor, your stator windings. That's all there is to it. So other than that switch going bad, there's really not a whole lot to go wrong. And that story I told you about the wash machine motor wouldn't start up, that's exactly what was wrong. The starting switch was bad, so it never engaged. So when you power it up, we only had the single winding just oscillating back and forth, and the shaft would just sit there and jitter. But give it a spin one direction, it would take off. Or give it a spin the other direction, it would take off. So it needs a little kick to get it going. Now, a true three-phase motor doesn't need that little kick. It's got a true rotation from the very moment it starts. So three-phase motors are favored in industry, but they're simpler, in fact, than the single-phase motor, fewer parts. Either way, you're looking at a very, very reliable machine. In most cases, the motor outlives the rest of the appliance it's put into.